Hi, we are SoundStage, a group made by Zachary Gerbi, Alejandro Reyes, Eric Ho, and Elias Lewin-Koh. And this is our final report for our 3D audio project. Just to recap, SoundStage is a VST plugin. And for those of you who don't know what a VST is, it's a virtual studio technology, which was made originated by Steinberg to do instruments and virtual plugins, which are incorporated into the DAW, which is a digital audio workstation. So everybody can use it who works creatively with audio, like musicians, like engineers, and producers. And the main goal is to modify a source sound to make it sound like it's coming from a user-defined position in 3 dimensions. Therefore, whoever is using this PST can simulate the sound coming from the top, from the right, from the back, etc. After our user study, it was intended to determine our accuracy from untrained subjects using our database from KIMAR, the KIMAR HRTF. And we were able to collect data from 4 participants, unfortunately with a 25% success rate, which was promising though, because even if it wasn't 100% or a pretty high success rate, we found that mainly the incongruences were coming from, for example, the cone of confusion, which are already known issues in the spatial audio. But this plugin and this project is still potentially usable, mostly intended for creators and for audio applications. So potential interest for these, we can probably invest in our plugin would be like major VST plugin developers, like for example Waves or Eventide. And as an addition, we can do the plugin in any digital audio workstation like Fruity Loop Studio, Ableton Live, Studio One, etc.
So we had a limited amount of time to develop this plugin in this semester, but future plans, if we had an extra semester, include smoothing the usage by implementing an overflow buffer to prevent the clicking that occurs between samples. We wanted to make more comprehensive and ubiquitous hardware integration so that anybody who has hardware as part of their creative flow would be able to use our plugin with minimal change to their work style. We would also like to implement a changeable HRTF selection so that our users could choose whichever HRTF suits the need that they're using it for the best. We would also like to clean up the UI and add a left-right mono selection switch so that users could select which channel creates the source signal for the mono signal that is fed into our plugin. If we had infinite time and resources, we would have liked to add interpolation between angles in our plugin. Right now, there are discrete steps for the azimuth and elevation that correspond to the data provided in the HRTF, but in the future, we would have liked to add interpolation between the different angles to create a continuous flow between the different steps. We would have also liked to add a switch between azimuth and elevation controls and XYZ controls so that a user could select whichever fits their work style best. Additionally, we would have implemented a faster convolution algorithm to reduce latency issues with our plugin and make the sound better.
So some challenges we faced when developing this plugin were having a long buffer delay, which caused a reduction in quality, loading HRTF data in C++, and this challenge was solved by writing all the HRTF data to a text file and reading that within our plugin. Translating between an XYZ coordinates and the azimuth/elevation values. This was solved by giving the user direct control of the azimuth/elevation values. Coordinating the hardware components and software components of our plugin. We solved this by mapping a joystick to predetermined MIDI controls and having that control the azimuth and elevation values. One big challenge was learning the Juice framework, which is a huge hurdle in itself because it is such a vast framework. Just getting the basics down is very hard to understand. And finally, balancing our realistic goals with our imagination. we decided to shoot for the stars in our project proposal, but then we had to bring ourselves back to the ground to be able to produce a plugin that's able to output exactly what we want. In the development process, we successfully implemented the HRTS in VST form for usage in production settings. As you can see in the picture on the bottom right, that is what our plugin looks like in FL Studio. The left control is the azimuth values. You can control that little knob in a circle, and that'll control which direction it's coming from. And then the right control is the height of the sound, so that'll determine if it's playing above you or below you. We have partially functional hardware integration. At the moment, we are able to detect MIDI signals from our hardware within Ableton, but not within our plugin yet, and that will be finished on the final deliverable. And finally, the simple and usable UI we achieved. You can see there's two knobs, two UI controls. It's really hard to mess that up. And now it's demo time.
This is a little trial of SoundStage regarding the custom joystick. So this is a launchpad from the C2000 family from the TI, and it's a processor with a custom PCB on top, which can read the MIDI. This was made by me for my senior design project. So these are the values that I was able to record as they go from 1 to 127. And he was on the maximum. Then I'll go to the regular, which is 64 value, around 62, 64, which is when it's in the middle. And as you can see, I was going up and I was going up and down using the joystick, and we're able to go up and down.
So in conclusion, we faced many unexpected challenges throughout our project development stages, and we were a little bit overly ambitious in our planning, but at the end of the day, we did create a product that achieves the intended basic functionality. Thank you for watching our presentation.